Warahmatullahi wabarakatuh dan selamat sejahtera. So in this video we still discuss about the constitutional isomers, but the molecule or the molecular formula is C5H10. Alright, so in this molecule it's only contain carbon and hydrogen. Okay, if we only have carbon and hydrogen, we have two possible compound. It can be alkane or alkene. Alkenes mean it's contain a double bond. Alright, so alkene means it contain all single bond. So if you have 5 carbon, the molecule can be like this, and we have hydrogen. Okay, so we have 5 carbon and hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So carbon is accepted, but the hydrogen is not accepted because we have extra hydrogen. So alkene, we cannot propose an alkene for this molecular formula. So maybe we can put, or we can consider as an alkene with the double bond. So if we propose an alkene, I think the answer is correct because now we only have 10 hydrogen and 5 carbon. So the structure can be an alkene. So the functional group isomers, okay, ataupun pasangan dia for alkene is cycloalkane. Cyclo mean it is a cyclic compound. Alkane, all are single bond. So to solve this problem, we need to propose an alkene and cycloalkane. So now first we go to alkene first. Kenes. Ke means it consists of double bond. So structure A, for example, 1 CH3 CH2 CH2. Oh, we want to put a double bond. Sorry. Okay, maybe we can put a double bond on the first carbon. CH2 double bond CH CH2 CH2 CH3. So 1, 2, 3, 4, 5. So this is structure A. The second one, maybe we can move the position of the double bond. So for B, maybe we can propose CH3 CH, position to number 2, CH CH2 CH3. So the difference is this is carbon number 1, we have double bond, and this is number 1 and carbon number 2. We have double bond. Okay, what about C? Can we propose this? CH2 CH double bond CH CH3. Can we propose this? Okay, we have to number these numbers to give the lowest number for the functional group. So in this case, the functional group is C double bond O. For B, we start numbering from here 1, 2, so that the double bond we get number 2. But for C, we need to start numbering from here 1, 2. So the double bond we get carbon number 2. So because of that, C is similar to B. We cannot propose this. This structure is not accepted. So why don't we shorten the number of carbon into 4? CH3 C CH3. Okay, let's say I want to put the double bond on carbon number 1, so I can reduce it. Double bond CH2 CH2 CH3. 1, 2, 3, 4, 5. So So this is considered as carbon number 1 and this is considered as carbon number 2. Okay, so why don't we move the position into here? Maybe our D is CH3, CH3 double bond, CH 1, 2, 3, 4, CH3. If we can see, this is carbon number 1, this is carbon number 2. At carbon number 2, we have double bond. At carbon number 2 also, we have substituent. So it is different from C. Okay, maybe we can still propose the same compound. CH3, C, CH3, H, CH double bond, CH2. Okay, can we propose this structure? Is that similar to C? So as I mentioned, we need to give the lowest number for the functional group. In this case, the functional group is C double bond O. C double bond C. So this is number 1, number 2, number 3. So it is at carbon number 1 is the double bond and the substituent at carbon number 3. It is different from C and also from D. So because of that, we can accept this structure. Right. So why don't we try to shorten the number of carbon into 3? 1, 2, 3. And we put a double bond here because we have 5 carbon. Can we accept this structure? Cannot, because look at this carbon. Carbon supposed to have only 4 bonding. In this case, it have 5 bonding. So this structure is not accepted. So because of that, we only have 5 structure for alkene isomers. Right. So now we go to cycloalkane. Kanes. Cyclo means cyclic. Okay, the first one that contain 5 carbon is pentagon. Okay. If you can see, each contain carbon and it's bonded to another 2 hydrogen actually. So because of that, this molecule have 5 carbon and 10 hydrogen. So it is accepted. Alright, so now I withdraw in the correct. Okay, saya cantikkan sikit. So the first structure that we can propose is this one. This one A, B, C, D, E. This is F. Okay. Then we can try to shorten the cyclo ataupun we can use FG. So we can propose the square that contain 4 carbon and we have 1 carbon extra as CH3 as a substituent. Then we can reduce the number of carbon cyclocarbon tu, cyclic tu into 3, which is a triangle. And we have another 2 carbon extra. So we can put as a substituent that contain 2 carbon this way. Or G, we can propose a triangle with 2 carbon like this. Okay. It's different from H. And we also can propose FG, H, E, F, G, H, I. This one is supposed to be I, right? I and G also triangle with both carbon. Okay, so we have 5 cycloalkane isomers and also 5 alkene isomers for C5H10. Now let's look at here. Can you identify a pair of chain isomer? So maybe we can propose A and D. What about positional isomer? This is one of the isomer. Positional isomer, maybe A and B. D and E also an example of positional isomer. What about the functional group isomer? Give me one example. You can take A and G. One alkene and another one is cycloalkane. So I hope this video will help you to identify the isomers for the molecule that contain only carbon and hydrogen. Okay, thank you very much.